Hey everyone, welcome back to my YouTube channel SummarizedAI. As part of this video, we are going to get complete overview and implement a RAG system that performs semantic search and allow you to pull fresh, up-to-date information directly from your database or documents in real time. This block might feel a bit boring at the beginning because learning the fundamentals can be challenging. Stay with the video for the next 10 minutes. By the end, you will gain clear and detailed insights that will put you ahead of everyone. Here, we will talk about what is RAG and C its implementation, PostgreSQL, PGVector database, vector embeddings, semantic and lexical search, best practices to follow while creating a RAG system. Let's first talk about RAG, which is Retrieval-Augmented Generation. As we know, AI models are trained on websites, blogs, code repositories, and many other diverse sources, which makes them generalized models because they learn from broad general purpose data. We call it pre-trained because the model is first trained on large general purpose data sets because it's used for specific tasks. Its knowledge is static or frozen and cannot reflect real-time data like current weather, stock prices, or breaking news. It will always refer to the information which it gets trained on. If you want to provide the latest, most accurate information on any topic, RAG is the right approach because it retrieves fresh data from your database or other sources before generating the final response. RAG gives AI the ability to look things up whenever needed into the database or other sources for the information. We can update the data in the database at any point of time. An AI model will fetch the latest information from the database to provide most accurate, current, and aligned response without retaining the model every time something changes. As part of this blog, we are going to implement RAG using blog posts that contains a title and description, and we may include additional metadata or fields as needed. Follow this highlighted blog having end-to-end information to set up PostgreSQL and vector database. As part of our current blog, we will store all the blog post information in a PostgreSQL vector database with the title and description saved as columns. Now, with title and description, we are going to have one more column as vector embedding. Everything here in this blog depends on vector embeddings. Let's see everything in detail. To generate vector embeddings, we will concatenate every blog post title and description and other metadata if available with the help of escape character, which is /n. This way, it will form a long string. Now, this particular long string we are going to convert into vector embeddings, and for that, we are going to use text embedding 3 small OpenAI model, which will allow us to create 1536 vector embeddings, every number separated by comma. Now, if we are going to use text embedding 3 large OpenAI model, it will create 3072 vector embeddings. This means the greater the embedding size, the better the result tend to be. This is a sample code where we are looping over all blog posts, concatenating metadata using a escape character, and then generate embeddings for the combined text. First of all, there are two types of vector embeddings. The very first one is static embeddings, and the second one is contextual embeddings. You can imagine static embedding as a multi-dimensional graph having 1536 dimensions, but we will simplify it to 2D or 3D for illustration. Each word or sentence is represented as a point in this space based on its meaning. Here, the word apple always maps to the same vector, no matter if you're talking about fruit or the company. The major disadvantage here is the model cannot distinguish context. So, a query for Apple revenue may incorrectly retrieve information about the fruit. In case of contextual embeddings, even though the word apple is the same, the context changes its meaning. The embedding captures these differences. Here, instance between vectors indicates semantic similarity. Apple as a fruit is closer to banana or orange, where Apple as a tech company is closer to Microsoft or Google. Imagine you are describing a fruit. If you only use one vector embedding as taste, your description will be weak. If you use five vector embeddings as taste, smell, color, shape, touch, your description will be better. If you have 1536 embeddings, your description would be simply detailed. Now, on what basis do we decide the vector length? You do not decide or choose the vector length. The AI model decides it by default for you. For example, here text embedding 3 small having 1536 vector length and text embedding 3 large having 3072 vector length, which means longer embedding vectors generally lead to more accurate and precise results because it has too many mappings to find that particular result. This is an example of PostgreVector database where how the data will be stored in the table, including the title, description, and their vector embeddings. So we can see here we have numbers separated by comma, and there are going to be 1536 numbers because we have created this vector embedding using the small OpenAI model. If we could have used the larger model, we could have 3072 number separated by comma. Now that our data is stored in the vector database, we can continue adding more information to our database to enhance our retrieval capabilities. And we are ready to start querying it. When we provide a search query, this search query also gets converted into a vector embedding. Now, these vector embeddings get compared with the embeddings of stored documents to retrieve the most relevant information based on semantic similarity rather than just matching keywords. Now, it is right time to discuss lexical and semantic search. Have you ever searched for something online and noticed that the search engine looks for the exact words you typed? That's lexical search in action. For example, you search for best chocolate cake recipe. A lexical search engine will look for document that literally contains best chocolate cake recipe. If a recipe says top cocoa cake guide or most demanding cocoa cake guide instead, it might not show up, even though means the same thing. So lexical search is all about matching words, not meanings. It's fast and precise when you know exactly what to look for. But on the other side, lexical search cannot handle synonyms, context, or meaning. It also misses relevant results if wording is different. But on the other hand, semantic search looks for the meanings or concepts behind your query, not just the exact words. It uses vector embeddings, which is a numeric representation of words, sentences, or document we just discussed. Convert query also to vector embeddings and compare with document embeddings to find conceptually similar content. in place of comparing the word. Just take an example of querying apple fruit. It will match documents containing red fruit, orchard produce, or even healthy snack because they are semantically related to apple as a fruit. It will not get matched to apple revenue as context here is all about the company, not the fruit. Let's talk about how semantic is better. Semantic search can understand context, synonyms, and natural language. It is also better for conversational search, knowledge bases, or RAG pipelines. But in terms of weakness, slightly slower due to vector computation and sometimes can return results that are loosely related or not exact. Now, let's talk about some of the best practices for RAG implementation using PGVector database. The very first thing is use high quality embeddings. As discussed earlier, prefer modern models like OpenAI text embedding small or large to have 1536 and 3072 dimensions or some other AI model to have high dimension for accuracy. And the second one is maintain the same embedding model consistently across your dataset. Clean and normalize your text before embedding. Choose the right chunk strategy where we can have chunk size of 200 to 500 tokens for any document. Also, avoid too small for low semantic meaning or too large for poor retrieval. The third is store chunk metadata also, such as source, section, and position to get more meaning out of the data. Now, the third and important point is to use correct indexing with PG vector based on dataset size. There is no indexing required if we have less than 20,000 rows. IVF flat is recommended for the rows in between 20,000 to 50,000. For rows which is greater than 100,000 or 1 lakh rows, IVF flat or NHSW indexing is strongly recommended. Use recommended cosine distance. Cosine distance checks the angle between two vectors rather than their length. This means it focuses on direction for meaning, not magnitude for sentence size. Cosine similarity performs best for text embeddings. Here, this particular symbol less than equal to greater than denotes the cosine distance. By default, cosine embedding didn't get enabled. We have to enable this by ourselves. It is good if we use hybrid search combining both keyword and vector scoring for best accuracy. It gives higher precision, reduces hallucination, helps with numeric or exact match queries. Finally, let's go ahead and start our implementation around drag. There is a problem statement we are going to cover here as part of our implementation. So we are going to use this dataset where we have multiple blog posts and every blog post is having title and content. We will concatenate every blog post title, description, and other metadata with the help of escape character /n. We will be using OpenAI's text embedding 3 small model to generate vector embeddings. We can use the large one, but at current point of time, we don't require that model. So let's go ahead with small model. Then we are going to store all the data and their corresponding vector embeddings in the PostgreSQL vector database table. Now, when we provide a search query, this search query also gets converted into a vector embedding. These vector embeddings gets compared with the embeddings we have inside the blog post table to retrieve the most relevant information based. Before we go ahead and see RAG implementation, we need to have PostgreVector database set up in our local. As mentioned in the start of the video, follow this blog having end-to-end information to set up PostgreSQL and vector database. Let's go to Visual Studio to start our implementation. Let's first create a file reg-dataset.py. Okay. Now, before we start our implementation, please run these commands in your local to install OpenAI. So you can go to the command prompt, hit this particular command, pip install OpenAI, something like this here in the terminal. And apart from this one, you can also go ahead and install pip install psycho pg2. So this psycho pg2 library will allow us to connect with our PostgreVector database. Now let's go ahead and start our development. Let's first import OpenAI. So we can say from OpenAI import OpenAI. Now after that, we require this psychopg2 also. So we can say psyco psychopg2. Now we require OpenAI key to connect with OpenAI library. So let's go ahead and get that. So we can say client equal to OpenAI API key equals to, and let me get the API key. I have already created a video how to generate an API key. You can go ahead and check out that video. Now we have OpenAPI key. After this, we are planning to connect with the PostgreVector database. So for that, we can create a connection equal to, we can say psychopg2 dot connect. Here you require some information like DB name. So by default, we are going to provide Postgres as the database. Now after that, we require the username. We can say again the default username as Postgres. And after that, we require a password. Here we can say admin. This is what I'm having, and I have set the admin as a password. Now apart from this, we require a host. So host is equals to localhost. So I am having this PostgreVector database in my local, and I will be referring to that. So that's where I'm going to give localhost. Apart from localhost, we can give 127.0.0.1 also, but I'm going with the localhost here. Great. Now, once you have this, you can say cursor equals to connection dot cursor. Okay. And this particular cursor will allow you to perform read, write, update, delete operations with the database. So I'm already having a data set with me. So I'm going to consume the same data set as part of this blog. So blog underscore data equals to this. So here we are having multiple blog posts, and every blog post having title and description. This is what we are going to use. Now we have our data set with us. Now what we discussed earlier, once we have our data set with us, we are going to loop through this data set. So we are going to say for title, comma, content in blog data. Okay. Now after writing this for, inside it, you can concatenate both title and description as discussed earlier. So for that, we can say combined underscore text equals to format. Then you can say title colon this, and then we have slash n. Then we can say content, and then the variable is a content. Great. So now we got our concatenated string. Now we are going to create the embeddings of this particular string. For that, what we are going to do, we are going to use our text embedding 3 small model from OpenAI. So let's do that. So emb equals to client dot embeddings dot create. Okay. And inside it, you have to pass the model equals to, so the model name is going to be text embedding hyphen 3 hyphen small. Okay. Now input is going to be our combined text. Okay. Great. Now this is done. Now here we can say data 0 dot embedding. This is what we are expecting. Great. Now, as soon as you got the response, it will take the 0th index item or element and it will fetch this embedding from that and it will assign it to the EMB as a variable. Now we have this cursor with us and we are going to write a query to get execute with the help of the cursor. Now here you are going to give three double quotes and inside it you are going to write insert into blog underscore posts, which is nothing but our table name. And here you can provide title, comma, content, comma, embedding. Okay. Now, after this, you can simply say enter and provide the values also. And here you just can say percent s, comma, percent oh, s, comma, percent s, comma, percent s. Great. Now you have this, and after this, you can say colon, enter, just provide the triple quote back and pass the variable names here. So title, comma, content, comma, embedding. Great. So our query is ready. Okay. Before we go ahead and execute this particular cursor, okay, I wish to showcase this particular thing here. So let me go ahead and remove this one and say print EMB. Okay. Let's see what happens when we do this. So let's clear the console, try to execute this code. You will see it will create the embedding and it will print all the embeddings. See, it printed all the embeddings. Now it's very tough to identify. So let's do one thing. We are gonna say this is the embedding for every sentence. Okay, and let me print this combined text also after this. Great. Let's re-execute. Great. Now the embedding got generated. Let's go ahead and copy one of the title here and try to search below. Yep, we found the concatenated or combined string as title and the content, and we have the respective embedding, which is 1536 item in an array, the numbers 1536 numbers, okay, which is nothing but it denotes the vector embedding, okay, as discussed earlier. Now we have combined text with us. We have title, we have description, sorry, the content and embedding. Now the title, content, and the embedding we have to store in our vector database. So for that, what we are going to do, we have just written a query, which is cursor.execute, and this will allow us to insert the title, content, embedding into the vector database. Great. Now let's do one thing. While saving these details into the database, let's print the title so that we will know what are the different blog posts we have inserted into the database. Let's do it. So here we can say title. Great. Once the cursor is done, we have to commit the changes. So we can say con.commit. Now, when I'm writing this con.commit, if I'm not going to write this particular line here, it will not commit these changes to the database. If I write this line here, it will commit the changes, which means it will save all the rows, title, content, and embeddings into our vector database. Now, once it is done, we have to close the cursor because the job is done. It is no more required. And at the same time, we have to close the connection also. We no more needed. Great. Now we have these things available with us. Now we are going back to our vector database and going to create a table. So, so you can see this is our PG vector database. Let's go ahead and go into the vector database. We have this PostgreSQL 16, and inside this we have Postgres. So this is the same database what we have given here. So when we were creating the connection here, DB name equal to Postgres, this is the same database name we have given there. So inside this database, we are going to create a table. So if I go here and click on this query tool, this query tool will help us to create a table. So we can say create table blog underscore post, and you can say ID as serial and primary key. So this particular ID will get generated automatically. And then after this, you have the title as text. And then again, content is also as text. Now, after this, we require one column for embedding. So we are going to say embedding, which is of type vector. Great. So it is 1536. This is what we know already. Now, if I go ahead and execute this particular query, it will create the table. So it is saying query returned successful in 242 milliseconds. Let's go ahead and right click, refresh this. You can see a new table got added. Now, if you wish to see the content inside the table, we can say select star from blog post. Okay. Now, if we execute this query, it says blog underscore posts. Okay. Oh my God, the name is, there is a typo. So let me go ahead and delete this table, correct this particular typo here. So blog posts, re-execute this particular query, refresh the table again. You can see the table here. Now, if we execute this query again, you can see we got the tables with the column, but we don't have any data here. So let's go back to our code base, clear our console here, the terminal, and re-execute this code. And this code will create the. Okay, we are getting one error which says this particular column is not there. Let's go back to our database. Yeah, I see there is one more typo. It should be embedding. No problem. Let's go ahead and quickly delete this table. Great. Select the query, execute the query. Done. Let's run the select. Nothing. Let's go ahead and clear the console and again execute the code. Now, this time it is inserting the block. You can see here one by one. Okay, this is done. Now, if we go back to our database and run this query again, select star from block post, you can see our data got saved inside the vector database. Now here, if you see, we have the title, we have the content, and the ID got generated randomly. And apart from this, we have got vector embedding here. Now, if I copy this vector embedding, okay, and if I go back to the Visual Studio, and if I say new file, paste, and if I try to search these commas, okay, so these commas are like 1535 times, which is means we have 1536 vector embeddings available separated by comma. Great. Now our embedding is ready. Now we can go ahead and make the query to search the data. Let's go ahead and create one more file, reg-query dot py. Okay. Now from this file, we will require this all code here. So we require from OpenAI, import OpenAI and import PsychoPG2. After this, we require a API key, OpenAI API key, and then we have to make the connection. Now we got all these things. Now we require to have our cursor. Okay, so let me copy that cursor also from here. So cursor equal to connection dot cursor. Fine. Now after this, we require a query text. So we can say query underscore text equals to how to do data analysis in Python. Let's ask this query. Okay. Now, again, because as we discussed earlier, we have to convert this particular query to embeddings. And the embedding which we are going to convert from this query is going to compare with the embeddings what we have in the database. So let's do that. Now, again, the same thing here. If I go back to this code here, let's copy this code. Okay, we have to create the embedding with the same model as mentioned earlier as part of the best practice. So you have to create the embeddings with the same model from which you have created the embedding for the data set. So here in place of this combined text, you are going to just pass this query text, okay? And update the variable to query embedding. Great. Now you have to execute the cursor. So we require a query here and we can say select from blog post order by embedding percent %s vector. Okay. Now after this, you have to say limit. We require only one as the output, and then just go in the next line and close this. Okay. And now we have to provide our query embedding here. Great. So now we are done and go to this. Now here we are going to say result equals to cursor dot fetch one. Okay. Now here after this we are going to say print the output simply. Great. Answers and you can say comma and then results of 0. Great. Now let me execute this piece of code and see the output. So here it is saying not all arguments converted during string formatting. Okay. So here we have select from blog underscore posts order by, okay, embedding this percent has vector. Great. Now let's execute this piece of code again and let me give the colon which is required. Let's execute this code again. Now you now let's try to execute this code here. So it is throwing an error. It says line 23, not all arguments converted during the string formatting. Okay, great. So this is one, this is there. Okay, this comma is missing here. Great. Now if I try to execute, so now we got the output and says answer Conda is the Python library for data manipulation and analysis. Learn to work with data frame, perform group by operations and visualize data. So this is how we can perform RAG, and at any point of time we can add more data to our database dynamically, and whenever we will make the query will always fetch the latest and updated result.